Hello once again. This is lecture 3 in our series, Power Generation, Operation, and Control. This is Bruce Wallenberg speaking. Lecture 3 has to do with industrial organization, managerial economics, and finance. What we're trying to get at here is to give you some idea of the business background to the electric utility or electric, just call it the electric industry. You notice here that we're differentiating regulated and deregulated, and we're gonna make a case here as to what those are. Originally, the U.S. and much of the world was structured to have regulated electric companies. Now, the reasons, there are lots of reasons why. If you look up the history, you'll find out that they originally were all kind of free market and competing with each other, and then they went to a regulated format. The regulated format lasted for an awful long time, till the late 1990s in the U.S. The regulated companies' prices were fixed by what are called public utility commissions. These are people appointed by the governor, let's say, of a state. Every state had their own commission. And the important thing for the companies was that the commissions, through many different processes and hearings and reports, came to a point where they would say, okay, you may charge this much, and they allowed the electric companies to make a quote-unquote reasonable profit. They were for-profit companies, but the utility commission set their prices at a level where they could make a reasonable profit. Now, in the U.S., the price of electricity actually came down over a long period of time. We have had many disruptions to the, especially the oil prices, and that has changed that trend somewhat. But over a long period of time, the price came down, and as utilities got more and more efficient and so forth, and took advantages of economies of scale. They were deregulated in the 1990s, and now generation companies compete to sell power. So the competitive power markets, generators must compete for business. They can compete for business in two ways. They can enter bids into a spot market and thereby compete with others in the spot market and gain business by putting in lower bids. Or they can make direct contact with loads, let's say large industrial or municipal power companies that buy large blocks of energy, and then they can negotiate the price directly. We call those bilateral contracts. And it's important that ultimately, if you live in states where they've taken this to the degree necessary, if you live in that state, you'll get offers from dozens of power suppliers, and then you get a bill that says, okay, you bought your power from a certain power company, meaning generator company, and then there's transmission charges, and then there are distribution charges, and so forth. The generators compete. We do not build duplicate transmission or distribution systems, so they're regulated, and basically they just put an add on to your bill. Loads can negotiate directly with multiple generator companies for the best price. So there's always that kind of direct negotiation going on over the phone or over the internet. Again, loads can enter bids into a spot market along with generation. Loads can say, I'll buy up to this much for this price, and then I'll buy even more if the price is lower, and so forth. So that within the market there, you end up with a supply and demand curve that are matched up, and that kind of matching is covered in our Chapter 11. The market operator runs an auction, again, to balance load and generation. That's where the crossover of supply-demand occurs, but it has to manage the transmission. Remember that this kind of system is a just-in-time, meaning that loads and generation, the purchase and sale, must happen simultaneously. Again, as we said before, the transmission and distribution owners receive payments for the use of their wires. Here's a diagram of the regulated utility industry. Way up at the top in the U.S. anyway, we had Federal Regulatory Commission. When I was younger, it was the Federal Power Commission. Now it's called the Department of Energy. Underneath that, a utility has to deal with the State Public Utility Commission to set rates. Sometimes there's independently owned utilities. Sometimes we have public utilities. Many small towns, cities have their own electric utility, and they buy power wholesale. Or they may generate it too, and so we deal with. You see in the diagram here, we have one state, then we have another state, and so forth, and we have all the states. Last of all, you can have government, meaning federal government held utilities in the U.S. The two biggest ones are, well, Bonneville Power, TVA. These are large hydro systems, although have incorporated a lot of thermal plants and other associations. So those are government held. Now the competitive market is structured very differently. Way up at the top here again, Federal Energy Regulatory Commission, or FERC, which is underneath the Department of Energy. And again, you have state public utility commissions, but you also have an organization such as it's called NERC, North American Electric Reliability Organization, or corporation now, which provides a lot of the standard settings, and this organization works hand in glove with the FERC, the NERC organization. And underneath this, we have generating companies, transmission companies, distribution companies, what we call load-serving entities, companies that simply may buy power and sell it to you, but they don't own any equipment other than a lot of computers. Energy Mercantile Association, independent agents that do contracting, and so forth, a similar kind of companies down here. The most important thing is that the competition is up at this level and a little at this level too. Transmission systems and distribution systems do not compete with each other. We're not going to go out and build two transmission systems and distribution come to your house and say, okay, hook up with the one on the left side of your house or the one on the right side of your house. That doesn't happen. Okay, now the initial vertical integration organization. This is to show you where the energy is coming from. The wellhead, okay, for either oil or gas. Mining companies up here. You have transportation companies, pipelines, trains, barges on rivers, trucks, to bring either coal or gas or oil. And we have government-owned agencies over here that may do similar, but mostly the government doesn't run mining or gas companies, but they run large hydroelectric companies. So down here we broke away gas utilities, and we have electric utilities. Now, these are regulated utilities, so you notice that we have generation, transmission, and distribution. All three of those in the regulated environment, the so-called vertically integrated systems, were all together. And down here we have all the customers that may be served by these, and gas utilities that sold natural gas to businesses and to people, houses for heating, as another utility, and serves the same customers down here at the bottom. The next one shows us the same kind of, we have the oil well, the coal mine, but here's a river system, here's a water reservoir, here's a hydro plant. We've broken out the plants because now these are competing entities. These are competing entities. And you can have a hydro plant compete with fossil units. Transportation is basically what we're showing here is, here's the transmission distribution. This is the electric over here, okay? So I'm just going to put E for electric. This is H, this is heating. Well, why does a power plant go into the heating network? Well, the power plant creates a lot of heat with burning coal, burning oil, gas, and in many places, large cities, the heat can be piped to businesses and homes around the city for heating and air conditioning. They can use that energy for both those purposes. So it becomes a separate transportation, if you will, of steam, usually. And down here we have our same customers again: manufacturers, industrials, commercial, residential. The last slide here is interesting. I want you to follow the red here. You should look at this slide as going across this way and then coming back. Okay, that's the way to read this slide. Was drawn this way because to fold it like that so that there's a large, it would be too large for the figure. We couldn't have gotten the text into all the different boxes in this flow chart. So we have coal markets, oil markets, natural gas, and we have generation companies that buy from these fuel suppliers, if you will. We have transmission companies, multiple transmission companies that basically are out there and connected into a large network. Then we have distribution. Now again, at the bottom part, things are going from right to left. So the distribution company may come into these energy service companies that are basically there to just arrange the whole chain with you and sell the energy to these final customers at the end. So the retail customer may get a bill that reflects something from the energy service company, something from the distribution, something from the transmission, and something from the generator. Oftentimes they're allowed to choose the generator company. Some of them, are claimed to be cheaper. Some of them may claim to be cleaner. They tout themselves as green supply, and so on and so forth. So we want to say the product, which is electric power, flows the way that one does. The cash, if you will, goes back the opposite way. We can draw that with a large dashed lines. So this is the cash. Going back this way. So as a business, product is flowing, in the clockwise direction around this loop. The cash starts at the lower left and flows counterclockwise. Thank you.